From the smallest grain of sand, a tiny speck that seems almost insignificant when held in the palm of your hand, to the largest star, a colossal ball of burning gas that lights up the night sky, everything we see around us is made of matter. But what is matter made of? What are the tiny components that come together to form the world as we know it? What are the fundamental building blocks of this vast and mysterious universe, stretching far beyond our imagination? The answer lies in tiny particles called atoms, the minuscule yet mighty entities that make up everything around us. The basic units of matter that form the foundation of everything we know. Atoms are incredibly small, so small that they are invisible to the naked eye. Imagine a single grain of sand, a tiny fragment of the beach beneath your feet. Now imagine that grain of sand being made up of millions of tiny specks, each one a building block of the universe. Each of those specks would be an atom. These atoms are the fundamental units that come together to create the world we see. Despite their size, atoms are incredibly important. They are the building blocks of all matter, the essential components that make up everything from the air we breathe to the stars in the sky. They combine and interact in countless ways to create the incredible diversity of materials we see in the universe. From the plastic in our everyday objects to the metal in our buildings, atoms are at the core of it all. Just as letters form words, and words form sentences, creating the language we use to communicate, atoms combine to form molecules. These molecules are the next step in the building process, coming together to create more complex structures. These molecules in turn create the objects, substances, and life forms that populate our universe. From the plants that grow in our gardens to the animals that roam the earth, everything is made up of these tiny particles. Understanding atoms is like unlocking a secret code, a code that reveals the fundamental principles of the universe, revealing the hidden language of the cosmos. This language is written in the interactions and combinations of atoms, the basic units of matter. By delving into the world of atoms, we can begin to understand the very fabric of our existence. We can begin to unravel the mysteries of the universe, exploring the fundamental principles that govern everything from the smallest particle to the largest galaxy, and our place within it. By understanding atoms, we gain insight into our own existence and the world around us. Join me on this journey as we explore the fascinating world of atoms, the tiny particles that hold the secrets of the universe, the fundamental building blocks of everything. Together we will uncover the mysteries of these tiny particles and their immense impact on our world. Atoms, despite their tiny size, are not indivisible. They are composed of even smaller particles, protons, neutrons, and electrons. Imagine an atom as a miniature solar system. At the center of this system lies the nucleus, a dense core that houses protons and neutrons. Protons are positively charged particles. They give the atom its identity. The number of protons in an atom determines what element it is. Neutrons, on the other hand, carry no electrical charge, hence their name. They reside within the nucleus alongside protons, contributing to the atom's mass. Orbiting the nucleus are electrons, tiny particles with a negative charge. Imagine them like planets whirling around the sun. Electrons are much lighter than protons and neutrons, and they are constantly in motion. Their movement and interactions with other atoms determine the chemical behavior of elements. These three subatomic particles, protons, neutrons, and electrons, work in concert to create the atoms that make up our universe. Their interactions and arrangements determine the properties of different elements and their ability to form the molecules that shape our world. The diversity of our universe is astounding, from the fiery inferno of stars to the delicate petals of a flower. But this vast array of materials arises from a surprisingly small number of building blocks, the chemical elements. Each element is defined by the number of protons in its nucleus, known as its atomic number. To organize this knowledge, scientists created the periodic table, a masterpiece of scientific organization. The periodic table arranges all known elements based on their atomic number and chemical properties. Imagine a grand library where each book represents an element. The periodic table is not just a chart, it's a roadmap to understanding the behavior of elements. Elements in the same column, called a group, share similar chemical properties. For example, the far right column contains the noble gases, known for their unreactive nature. The periodic table is a testament to the elegance and order of the universe. It showcases the incredible diversity that can arise from a limited set of building blocks, each with its own unique characteristics and potential for interaction. Section 4, the weight of the universe, protons and neutrons. While electrons contribute to an atom's charge and chemical behavior, the bulk of an atom's mass resides in its nucleus. This nucleus is a dense core at the center of the atom, composed of protons and neutrons. These particles are bound together by the strong nuclear force, one of the four fundamental forces of nature. Protons and neutrons, those tiny particles huddled together at the atom's core, are responsible for an atom's weight. Protons carry a positive charge, while neutrons are neutral, having no charge. Despite their small size, they are incredibly dense and contribute significantly to the mass of the atom. Imagine holding a bowling ball and a tennis ball. The difference in weight between these two objects can help us understand the distribution of mass within an atom. The bowling ball, like the nucleus, holds most of the weight. In contrast, the tennis ball, representing the electrons, contributes very little to the overall mass. Each proton and neutron has a mass of approximately 1 atomic mass unit. This unit is a standard measure used to express atomic and molecular weights. The total number of protons and neutrons in an atom's nucleus determines its atomic mass. This is why elements with more protons and neutrons are heavier. This mass is what gives substances their heft and plays a crucial role in gravitational interactions. The more massive an object, the stronger its gravitational pull. For example, the element gold, with the symbol Au, has 79 protons and 118 neutrons in its nucleus. This combination of protons and neutrons gives gold its significant atomic mass. This gives gold a high atomic mass, making it a dense and heavy metal. The density of gold is one of the reasons it has been highly valued throughout human history. The atomic mass of an element influences its physical properties, such as its density, melting point, and boiling point. Elements with higher atomic masses tend to have higher melting and boiling points. Understanding the role of protons and neutrons in atomic mass helps us comprehend the physical properties of matter and the forces that govern the universe. This knowledge is fundamental in fields ranging from chemistry to astrophysics. From the density of planets to the fusion reactions in stars, the mass of atoms plays a fundamental role in shaping the cosmos. The processes that occur in stars, such as nuclear fusion, depend on the interactions between protons and neutrons, ultimately influencing the life cycle of stars and the formation of elements. The periodic table itself is a map of these interactions, showing how elements are formed and transformed in the heart of stars. By studying protons and neutrons, we gain insight into the very fabric of the universe and the forces that hold it together. So next time you look at a periodic table or ponder the weight of a gold ring, remember the protons and neutrons at the heart of every atom. They are the building blocks of matter, the key to understanding the universe's mass and the forces that shape our world. Section 5. Atomic interactions, the dance of energy. Atoms are not static entities, they are constantly buzzing with energy. These tiny building blocks of matter are in perpetual motion, driven by the forces and energies that govern their behavior. Electrons, those tiny particles orbiting the nucleus, are the key players in this dance of energy absorption and release. They move with incredible speed and agility, creating a dynamic environment within the atom. Imagine electrons as dancers moving between different energy levels within an atom. Each level represents a different state of energy, and the electrons can transition between these levels, much like dancers changing their steps to match the rhythm of the music. When an atom absorbs energy, its electrons can jump to higher energy levels, like dancers moving to a faster rhythm. This energy can come from various sources such as light, heat, or electrical energy, causing the electrons to become excited and move to a more energetic state. This energized state is temporary, and electrons will eventually return to their original energy levels. As they do so, they release the absorbed energy, often in the form of light or heat, much like dancers returning to a calm and relaxed state after an intense performance. As they do so, they release the absorbed energy in the form of light or heat. This release of energy is a fundamental process that occurs in countless natural and technological phenomena. This process of energy absorption and release is fundamental to many phenomena we observe, from the vibrant colors of fireworks to the warmth of the sun. The brilliant display of fireworks is a result of electrons releasing energy as they return to their original levels, while the sun's warmth is due to the continuous energy exchanges occurring within its core. Chemical reactions, which involve the breaking and forming of bonds between atoms, are also driven by these energy exchanges. When atoms interact to form new compounds, they absorb and release energy. driving the reactions that are essential to life and industry. Understanding how atoms absorb and release energy allows us to explain a wide range of natural phenomena. From the glow of bioluminescent organisms to the energy produced in nuclear reactions, these principles are at the heart of many scientific discoveries. It also forms the basis for technologies like lasers, solar panels, and countless other innovations that rely on manipulating the energy levels of atoms. By harnessing these energy exchanges, we can develop new technologies that improve our lives and expand our understanding of the universe.